Okay, now we're going to graph exponential functions, which we've done before, so I'm going to go through this a little bit faster. So we have exponential parent functions. So let's just start with the first one. We're going to make a table, x and y. And if you look on the right, the example says we're going to do y equals 2 to the x power, which is the one we've been working on like towards the beginning of the year with the parent functions. This is the one that we use most of the time. Okay, so if we have a base of 2 and our x is negative 2, 2 to the negative 2 power is going to give you 1/4. That negative exponent flips it. 2 squared is 4. When x is negative 1, it will be 1/2. 0, 1, 1, 2, 2, 4. So we're going to plot those points on our graph. Negative 2, 1, 4 is going to be a little hard to plot. Negative 1/2 is a little bit easier. 0, 1, 1, 2. Alright, and we've talked about domain and range of exponential graphs before. Like I said, I'll go through it kind of fast. Domain is your x's. So it's your x-axis. It goes from left all the way to the right. So this one goes to the left for forever, and then goes to the right for forever and ever. So my domain would be negative infinity to positive infinity, or you can put all real numbers, either one. The range is different because it doesn't go down forever and ever. It has a boundary point. That horizontal asymptote is the boundary point. So it's going to start at 0. And then it's going to go up forever and ever. Now, since it doesn't actually touch 0, we put a parentheses instead of a bracket. That's just saying it doesn't include 0, but that's the boundary. It gets really, really close to it. Or you could say y is greater than 0. My asymptote, I have a horizontal asymptote with exponential functions, which means I'm going to have y equals. If it's horizontal, it goes through the y-axis. So anytime it goes through that y-axis, it's going to be y equals. Okay, and it goes through where y is 0. So y equals 0. All right, some characteristics about this graph would be that your y is increasing from left to right. So from left to right, my y is getting bigger. That would be a characteristic. So you can put y or f of x, they're the same thing. The f of x is increasing. The other characteristic is that you have a horizontal asymptote at y equals 0. On the bottom right, it says all exponential functions will go through blank. We're only going to use the first blank because all exponential functions go through the point 0, 1. Which is kind of cool, and the reason it does that is because anything to the 0 power is 1. So I could have negative 512 to 0 power, and it's still going to be 1. So that's why exponentials will always go through this point. All right, let's next one. The next graph at the top, it says y equals 1/2 to the x power. Okay, so our base is 1/2 this time. So let's fill in our table. When x is -2, if I take 1/2 to the -2 power, okay, that negative is going to flip it. So I'm going to get 2 over 1, or just 2 squared. So 2 squared is 4. When x is -1, 1/2 to the -1 power would just be 2. 0, 1, 1, 1/2, 2, 1, 4. And we're going to plot those points. -2, 4, -1, 2, 0, 1, 1/2, and 2 1/4 is going to be hard to plot. So go ahead and draw your curve. Okay, and you can see it still goes through the point 0, 1. Even though it's going a different way, like this time my y is decreasing, it still goes through the point 0, 1. Okay, and it'll do that until we try to move it up or down. It'll always go through the point 0, 1. So our domain is our x's. It goes to the left forever and ever, and it goes to the right forever and ever. So it'll be -infinity to positive infinity for all real numbers. The range is kind of like the last one. We have a horizontal asymptote at y equals 0, right? So it gets really, really close to it, but it doesn't actually touch it. So it's going to start at 0, and then it's going to go up forever and ever. So 0 to infinity. Make sure they both have parentheses. Or you could say y is greater than 0. The next part is the asymptote, and we just said that there's an asymptote at y equals 0. Characteristics about this graph, we kind of already said it. If you look at this graph, your y is decreasing from left to right. You always want to go from left to right, like you're reading a book. So my x's, I go from left to right. And when I do that, my y is getting smaller and smaller until it gets close to 0. So a characteristic would be that f of x is decreasing this time, and that you have a horizontal asymptote at y equals 0. And that horizontal asymptote will always be at y equals 0 until you start moving it up or down. Okay, so the base doesn't really matter. You'll always have that point at 0, 1, and you'll always have a horizontal asymptote at 0. All right, next page. The next page says determine what happens to parentheses 1 plus 1 over n to the n power as n approaches infinity. So that means as n gets bigger and bigger. Alright, so let's go to y equals on our calculator. And we're going to put in 1 plus 1 over n to the n power. And we're going to fill in this table. Okay, so we have parentheses 1 plus 1 divided by n, or x. N and x are the same thing, they're variables. Close parentheses, and then to the n power, so caret x. Okay, and we want to look at the table. Okay, so press second graph. Once you have all that plugged in, y equals, press second graph to go to your table. And when x is 1, my y is 2. When x is 2, my y is 2.25. When x is 5, my y is 2.4883. 10, if you scroll down, you get 2.5937. Now, if we keep scrolling down to where x is 100, it's going to take us a long time. So instead of just scrolling down the whole time, what you can do, do y'all see table set written in blue above your window button? Press second window, and you can change where your table starts. So we want to know when x is 100 what our y is. So we can start our table at 100, press enter, and then you're going to go back to your table. So the table start's going to be at 100, press second graph. So when x is 100, my y is 2.7048. It'll take you straight to that point. Okay, so that's what we'll do for the rest of these, so it goes a little faster. Okay, so we want to know when x is 1,000, so go to table set, second window. I'm going to change that to 1,000. Press enter, and then go back to my table. And it's going to take me right to where x is 1,000. And my y will be 2.7169. Okay, go ahead and fill out the rest of your table. So 10,000, we need 100,000, and then we need 1 million. So you should get 2.718 for 10,000, 2.718 for 100,000, and 2.718 for a billion. So you see how it starts to kind of level out, and so what's going on is your y is getting closer and closer and closer to this 2.718. Okay, so on the right side of that table, it says, as n approaches infinity, so n is the same thing as x, as our x gets bigger and bigger and bigger as it approaches infinity, my y, or my equation, it says 1 plus 1 over n to the n power. Okay, so my y is going to approach 2.718. And at the bottom, it says the number e is an irrational number defined as the number that the quantity 1 plus 1 over n to the n power approaches as n approaches infinity. So e is what we just figured out, 2.718. And we'll use this a lot more with natural logs, logarithmic equations, stuff like that. It's almost like pi. How pi is a number. It's a really, really long decimal, but it represents a number. E is the same thing. E actually represents a number, this lowercase e. And if you round it, because it is a very long decimal, if you round it, it equals 2.718. And this is actually on your calculator, E. Just a little FYI. If you look on the left side of your calculator by the number 4, you see that LN button? That's for natural log, and we'll do that later. But written in blue is e to the x power. That e is what we're talking about. It represents 2.718. All right, so next page we're actually going to graph e to the x power. Okay,